Hello, learners in YouTube world. This is Dr. Satish Singhal, PhD, Professor of Computer Science at El Camino College, Torrance, California. I'm going to do two videos in a row to explain formatting of real numbers in C++. This is part one. In this video, we are just going to talk in general about real numbers or floating point numbers and what functions are available in C++ to format them. So let's proceed. Real numbers have a whole part or an integer part and a fractional part which is always less than 1, and you can call them as fractional digits. Both parts can be 0. I'm showing examples of some of them here. For example, you have 0.0. Here both parts are 0. You have 2.0. Here only decimal digits after dot are 0 but not integer digits before the dot. You have example like 0.112. Here integer digits are 0, but decimal digits are not 0. And then you have something like 3.159, where no parts are 0. No parts are 0 in these as well, except this has two figures before the dot, two integer digits, and here you have 1, 2, 3, 4, 5, 6 integer digits. There are many nomenclatures for two parts of real number. Part before dot can be called integer digit, but it's also called characteristic. Part after dot can be called decimal digits, but it's also called Mantissa. We are going to follow the words characteristic and Mantissa, but we'll follow also the words such as integer digits and decimal digits. In real world, the real numbers are represented in fixed format. All these are fixed format, although number of decimal points shown is not fixed. In a real fixed format, there will be fixed number of decimal digits in each number shown. And in C++, there's an output manipulator called fixed that accomplishes the display of numbers in fixed format. And these are the example of fixed format, although number of decimal points in a real fixed format would be same. Okay. Now, scientists many times do not use fixed format. Rather, they use an E format where real numbers are shown as below along with their fixed format. So for example, 0.0 E plus 0 is the E format, and that's the fixed format for that number. These are same number that we saw on previous page, all these. We're just giving E format or scientific format and fixed format side by side. 2.0 E plus 0, scientific format, fixed format. 1.12 E minus 1, scientific format, fixed format. And I'm just gonna shut up for a second so you can see the others as well. Okay, we're just gonna show some examples of converting from E format to fixed format. For example, we have this number here. Meaning of that is that it is 1.12 multiplied by 10 power minus 1. So where there E is, you replace that by 10, and this number becomes power of the 10, and that would simply means that you have 1.12 divided by 10, and that will become 0.112 in the fixed format. So meaning of 4.3129 e plus 1 is that you take the number before e, multiply that by 10 to the power 1, that will become 4.3129 into 10, or 43.129 in fixed format. Okay, that's the conversion from one to the other. In E format, generally no more than one characteristic digit is shown. You can see in all these. In the characteristic part or integer digits, there is just one digit. The rest of the digits from characteristic, if there are any, are folded into Mantissa, and then E plus n or e minus n are adjusted accordingly. N is the power of 10 multiplied by to the number before e. So for example, here in fixed format you have 499,876.1245. In order to show this in e format, I'm just going to count 1, 2, 3, 4, 5. I'm going to put the dot here, and that way I get this number, and then I'll put after that e plus 5, meaning that when I expand from here to here, I'm going to multiply this part by 10 to the power 5 to get that. Okay, so that's the expansion from one format to another. You should know this very well in order to understand both systems. In C++, E format is induced by using a manipulator called scientific, and we'll talk about that when we show in part 2 the actual code. Okay, how are real numbers stored in computer? First, let us become aware that in computer science, real numbers are called floating point numbers. This is because in scientific or e-representation, one can float the decimal point to various locations and adjust the integer after e accordingly. For example, take 154.112. This can be represented in few different ways by floating the decimal point. So if you represent it as 1.54112, then we have plus 2 after e, because we in order to convert from this to this, we divide it by 100, and that 100 is 10 to the power 2, so that has to be multiplied again here. So when we are expanding, we'll expand that as 1.54112 into 10 to the power 2. And you can represent same number this way also, this time floating the dot one more to the right. When you do that, this power will go down by 1. And if you float it one more time to the right, then this power will become 0. So same number by floating the decimal point can be represented in 3 different ways. That's why we call real numbers as floating point numbers. Okay. So in these examples, the decimal point has floated to different locations in the number as per change in the power after e. Okay. That's the explanation for why we call real numbers as floating point numbers. And henceforth, we'll use the term floating point numbers for real numbers. Okay, the integer part of the floating point number is storable precisely in the computer, but we can't say the same thing about the Mantissa part. The Mantissa part of floating point number is stored in computer either exactly or imprecisely, depending upon whether Mantissa can be built by adding fractions such as 1 divided by 2 to the power n, where n can vary from 1 to infinity. Infinity is just a large practical number. And this topic is a different topic. We'll explore details of this topic in another educational unit. but suffice to say that at times exact storage of Mantissa or floating point number may not be possible. All right. Displaying or formatting floating point numbers. So displaying the floating point numbers the way we want them to look in our output is called formatting floating point numbers. Now, it is important to understand the topic of formatting the floating point number only relates to displaying them in an output from the computer. No formatting technology changes the actual stored value of a floating point number. Anything you do in formatting and getting a display of certain number does not change the stored value of that number inside the computer. Okay? You can only change numbers in the computer by doing arithmetical operations on them. But once operation is over, you can't change them unless you do another operation on them. Okay? Formatting does not change stored values of floating point numbers. So you can think of formatting as a mask placed on the number so that it can look certain way, and that way is preferred form of viewing. In formatting process, following operations may be desired. Even if Mantissa is 0, its 0 value is displayed. In this case, floating point 3 is not displayed as 3, but is displayed as 3.0. There is a function in C++ called showpoint that helps that process. The second operation is that significant digits displayed are controlled. For example, 54.119 has 5 significant digits. But if we wish to show only 4 significant digits, then including the approximation, it will show as 54.12 because 0.19 has been approximated to 2. There is a function in C++ IO manip library called setPrecision that helps us control how many significant digits are displayed. And then third operation is the number of digits shown in Mantissa are controlled. For example, we can show 54.119 as 54.1190, 54.11900, or 54.12. In this example, the number of digits in Mantissa vary from 2 to 5. 2 here, 5 here. Combined with the manipulator fixed, in C++, setPrecision can achieve our objective of controlling number of digits in Mantissa. And we'll see that in the code examples in part 2. So this was the basic introduction. And before you go further, you should learn the meaning of these following terms. Learn the meaning of following terms to add to your C++ programming vocabulary. All through this presentation, the key terms whose meaning you should know are shown in red, and they are listed below once again. You should know what are real numbers. You should know what is characteristic. You should know what is Mantissa. You should know what are floating point numbers. You should know what are the manipulators. You should know what is fixed format or scientific or E format. You should know what is the manipulator scientific in C++ and what does it do. You should know what is the manipulator fixed in C++ and what it does do. And you should know what is manipulator setPrecision in C++ and what it does. And you should know what is manipulator showpoint in C++ and what does it do, and what is the meaning of significant figures. Of course, all these will become more clear in part 2 when we actually show you code examples. Okay? So for now, goodbye from part 1 for formatting of real numbers in C++. This is Dr. Satish Singhal saying thanks to you.